Okay, we're going to wrap this up with these last three tabs of bake, data, and parameters. We'll go through these pretty quick. Start off with the bake. So we have our bake objects, bake modify layer. If we add a layer right here, activate or place a button. That can also, the button can be triggered by a 0 or a 1. So if you had a change of a script that wanted to add a layer, that's what the bake button is for. So we can add that layer. If you wanted to get a little more control, you could define the layer first. Define layer and add a swatch for color. And that's going to modify our layer. If we change the name of the layer, it's just going to add an additional layer, not change the name of the original layer. Unlike changing the color, changes whatever is here. Another good one to know is you can add sublayers with 2 semicolons, like so. And push our button, and now we have a sublayer. And you can keep going with that if you wanted to. So that's pretty much it for the modify, bake and modify layer, as well as define layer. Bake objects, seen some of this in the earlier ones. Key thing to know is about the bake name. So if we have our box going in here, and we add a bake name, it replaces our objects. Once again, we can trigger that with a boolean or a button. So now when we bake our box, we were going to have a different size box, and we wanted this to replace our old box here in Rhino. The bake name is going to replace everything in it. One key thing to note is, so if we're making a series of boxes, structure point, a little more space, go smaller. One key thing to note, we can graft our objects, but this needs to be a single value. It can't be multiple bake names. It's always going to be one bake name per set of objects. But as you can see, this is extremely useful when working with Rhino and Revit. We've already covered the attribute aspect, so I don't think we need to go into that. The big thing is, yes, bake name, and then aligning your attributes, which we covered in section 3. So let's keep moving on to our data. A couple of these I use a lot, and then the other ones are, sure there's a good use for them. I just either different ways of working with them, but we'll take the ones that I use all the time. So that's probably going to be duplicate data match, create tree, and clean parallel. So if we have a series of, we have a list that for some reason had a bunch of empty or null values, we can quickly clean those out. Right? But there are a lot of cases where you still want to keep the branching. So when we graph these, we kept the branching, but we might not want all these empty branches. So that's where the retain empty and remove empty option comes in handy. So it keeps your branches 0, 1, 4, 5, 8, 9, and removes the other one. If you wanted to keep the empty ones, you go right here. Duplicate data match. You can kind of use this same example. Here's our null data, and then data to match right here. It's going to leave these branches, but it'll fill in for our values. If you do clean the tree or don't clean the tree, it's going to add in values for those empties, which most of the time isn't desirable. So you'd want to remove your empty branches here. So now we would have matching lists. So duplicate data is going to duplicate your data based on the source data tree. Clean parallel, either removing empty branches when you have trees. The next one I want to go into is the create tree. So create tree is looking for data and then a path. So if we do a duplicate data match, we're going to do a character sequence. This one, 3. So now we have our ABC, and that's going to create each value each time. So we have 10 objects, so it's going to create 30 different ABCs. If we wanted to branch these into their respective ABCs, and these could even be totally randomized at this point, we'll create a set. And the set's going to give us our unique items, and then it's also going to give us the index of the original item. So if we're going to create a data tree from these items, we could use, this is our 30 items of data. Here's our 30 tree branches, and that's going to output, using the right data, branches containing only those values. So that's how you create a tree, is using that create set data information. Do it a little bit better, so it's ordered ABC and ABC. Graph parallel. Graph the primary tree and output all respective secondary objects per item. Pretty self-explanatory. As is shift match. It's kind of that, doing the same thing as a trim tree, but you're matching a guide tree to the shift. So we had, let's just graph these elements. Actually, let's graph these elements where we had 3 branches of 10 items. Now we've got a shifted list. If we wanted to move this back to our original data structure, we could shift that back. Like I said, I usually use trim tree in this case. Shortest clean list, very similar to longest and shortest list, but this one is performing more clean as well. Going on to number 8, parameters. Once again, these aren't ones I use very often. The bake Elefront is pretty self-explanatory. We got rid of our bake name, but for all bake object components here, here, and we had another one with a box. And we baked all. It's going to put both of those into our file. Pretty handy. The EF data description. This is for, it's kind of, this came out before we put in the relay, because you can kind of do the same things with the relay name. So this is a box, and this is a data description. Like I said, I don't use this one very much. Extended geometry is actually pretty useful, because it's really the only way to, I was going to create a block, Rhino block, and I wanted to reference that we don't have a block component as a native geometry in Grasshopper, at least in Rhino 7. The extended geometry will allow you to bring in your block this way, so then you could start using your deconstruct block. So that's pretty much, extended geometry will hold about any sort of geometry that you're going to need from Rhino. So to recap, we go back to Elefront, bake, big thing is the bake name, bake modify layer, double semicolon, we'll add sublayers. Clean parallel is great, use it all the time. Create tree, very handy. Duplicate data match, handy as well. Don't generally use these 3. And then our extended geometry. So that wraps these up. Thank you very much.